The given identity that we're going to prove is sine x plus tangent x over 1 plus secant x equals sine x. So, we're going to solve the left side. So, the first step, we're going to express tan x and secant x in terms of sine and cosine values. So, let's just copy sine x plus tangent x, its cosine and sine value is sine x over cosine x over 1 plus secant value in terms of sine and cosine value is 1 over cosine x. And just copy the sine x. Now, let's proceed to the second step. So, we're going to do is to get the less common denominator. So, the less common denominator of both numerator is cosine x. And now, our expression simplified to equal sine x cosine x plus sine x over cosine x over cosine x plus 1 over cosine x, and just copy sine x. Since the fraction is complex, let's simplify to get the product of this fraction. Sine x cosine x plus sine x over cosine x multiply by cosine x over cosine x plus 1. And next, we cancel out the terms that are the same. So let's cancel cosine x here and here. So this going to sine x cosine x plus 1 over cosine is going to be 1 multiply by 1 over cosine x plus 1. So we're going to cancel out the same terms, the cosine x plus 1, and the final answer is sine x equals sine x. The second identity that we're going to prove is 1 minus cosine x over sine x equals to sine x over 1 plus cosine x. In this identity, we're going to solve the right side. So the first step is to multiply both numerator and denominator by sine x. To be sine x over 1 plus cosine x multiply by sine x. Then, let's multiply sine x in numerator and denominator. Now, let's analyze the numerator. Sine x times sine x is equal to sine squared x over 1 plus cosine x and sine x. Now let's apply the Pythagorean theorem. which is the identity is sine squared x is equals to 1 minus cosine x squared. Going to be, so 1 of 1 minus cosine squared x. Now let's rewrite the fraction. So 1 minus cosine squared x over 1 plus cosine x and sine x. Now, let's apply the difference of two squares. Let's substitute the numerator. 1 minus cosine x. 1 plus cosine x over 1 plus cosine x and sine x. Now, let's cancel out the same value in the numerator and denominator. 1 plus cosine x. And the final answer is 1 minus cosine x over sine x. Now, let's proceed to the third identity. 2 tangent x is equals cosine x over 1 minus sine x minus cosine x over 1 plus sine x. To simplify this expression, first we need to find the common denominator. The common denominator of two fractions is 1 minus sine x and 1 plus sine x. So it would be 1 minus sine x and 1 plus sine x is equals to 1 minus sine squared x. Now, let's use the Pythagorean theorem, which is the identity is 1 minus sine squared x is equals to 1 minus sine squared x is equals to cosine squared x. Next, rewrite the fraction. So, you're going to be cosine x 1 plus sine x over 1 minus sine squared x minus cosine x 1 minus sine x over 1 minus sine squared x. Next, combine these two fractions into the single fraction. So, going to be equal cosine x 1 plus sine x minus cosine x 1 minus sine x over 1 minus sine squared x. Next, expand the numerator. So it is going to be equal cosine x 1 plus sine x minus 1 minus sine x over 1 minus sine squared x. Next, distribute the expression. So this is going to be equal cosine x 1 plus sine x minus 1 plus sine x over 1 minus sine squared x. Next, we use the Pythagorean theorem, which is cosine squared x equals to 1 minus sine squared x. Since we use the Pythagorean theorem, the identity become cosine x 2 sine x over cosine squared x. Now, let's cancel out the numerator and denominator. This and this. Going to be 2 sine x over cosine x. Next, break it down into two fractions. So, it's going to be equal 2 sine x and cosine x. Since x and cosine x is same in tangent x, so the final answer is 2 tan x.